And I'm going to give you a brief introduction about a few components of simulation. Monte Carlo simulation will give you accurate dose calculation in radiotherapy. So some of the algorithms such as pencil beam, convolution, superposition have some limitations, especially in the heterogeneous medium. To overcome this limitation, we need Monte Carlo simulation. So Monte Carlo methods provides benchmark accuracy by simulating physical interaction explicitly. What is Monte Carlo simulation? Monte Carlo simulation is a mathematical and computational technique used to model complex systems and processes that involve randomness or uncertainty. It relies on a repeated random sampling to obtain numerical results, which means it runs a process thousands or millions of times using a random input, then analyzes the distribution of outcome to estimate probabilities, averages, and uncertainties. To understand this Monte Carlo simulation, let's consider an experiment. In this experiment, we have two containers. One is in square shape and the other one is in circular shape. Above this containers, there is a one arrangement which drops the balls randomly inside and outside of these containers. So below these containers, there is a counter which counts the number of balls of of these containers separately. So as for after some time, in the initial stage, we couldn't get any useful information. But after some time, if we take the ratio between the number of balls which are collected in the circular container to the balls that are collected in the square container, which approximately will give you the value of pi, which means we are indirectly measured the or derived the pi value. Uh, that is the beauty of this randomness. Uh, so if you take some unbiased random sampling with some iteration for example, some millions of time, we could able to get the true value of that particular system. So that is the basic concept of Monte Carlo simulation. So this is also one of the example for this randomness. So if we flip a coin, the probability to get head or tail is 50-50. If we do this for 100 times, the probability to get tail is increased to 53%, which means we are doing some random things with the unbiased random sampling. We could able to get the true value. So this is based on the law of large numbers. When we do the random sampling, we could get the true probability. So that is the basic concept of Monte Carlo simulation. So this Monte Carlo simulation has been used for so many fields, for in the finance, engineering, nuclear physics, computer graphics, in medicine, especially in radiotherapy. You are using this Monte Carlo simulation for radiation measurement. So if I say we need to do the random sampling, we need to we need to calculate the probability. Some of them might be think that we need to do some so many calculations, so many complex calculation. We need to get this Monte Carlo simulation to easy all these things. There are toolkits are available in the online platform. So these are all the some of popular toolkits which are based on this Monte Carlo simulation. So on these toolkits, today we are going to see only about the EGSnrc toolkit. So EGSnrc stands for Electron Gamma Shower National Research Council. It's a Monte Carlo simulation system designed to model the transport of electrons and photons through the matter, which will give you a most accurate calculation, and it has been widely used for radiation dosimetry, radiotherapy, and radiation protection. So this is the brief history of EGSnrc. In the early of it was developed by Stanford Linear Accelerator between in the year of between 1960 to 1970. They named as EGS, and it has slowly evolved. And in the early of 2000, Canada's National Research Council adapted this package for the medical physics purpose, and they named this as a EGSnrc. And still they are updating this toolkit. This is the basic architecture of EGSnrc. So EGSnrc contains so many components or so many modules. Some of the modules runs on Morton language, and some of the modules runs on C++ language. So these are all the modules you can able to see. BEAMnrc, DOSXYZnrc. These are all the main components of the EGSnrc toolkit. So we'll see these modules one by one. First, BEAMnrc. BEAMnrc is mostly used for linear accelerator modeling and X-ray systems, which includes most of the geometries such as flattening filter, collimator, MLC, and these accelerator can be compiled as shared library to be used as a particle source for other applications, which means we can construct the linear accelerator by using the BEAMnrc, and using this BEAMnrc, this constructed linear accelerator, we can use that accelerator for other applications such as DOSXYZnrc, and there are so many applications are there. And DOSXYZnrc, this model is basically used for the dose calculation in the voxelized phantom. This model is basically used to construct the phantom to calculate the dose distribution. It includes the variety of source models which was shared in BEAMnrc library, and these are also some of the applications of EGSnrc. So DOSRZnrc is mainly used for dose and kerma calculation. CAVRZnrc is used for correction factors which are used in ionization chamber. FluRZnrc is used for particle fluence calculation. SPRRZnrc is to calculate the stopping power of the to calculate the stopping power ratios. So RZ is denoted for this geometry. Basically, this application has two geometries. One is cylindrical geometry, another one is spherical geometry. These four components are used for cylindrical geometry, and these two modules is used for spherical geometries. And another one is most important and very useful application is G. G, with the help of this application, we can find the energy transfer coefficient, energy absorption coefficient, and G bar. So whatever we have seen till whatever we have seen is based on this Morton language, and some of the applications runs on C++ language. For example, EGS chamber, which is used for dose calculation in ionization chamber, and EGS CBCT is a module to estimate. It is used for fast estimation of scatter contribution to an ideal detector, for example, cone beam CT. We can use this model for construction of the CT also. And EGS FAC is used for free air chamber correction factors. Cavity is also an application which is also used for calculation of the ion chamber correction factors. So let's talk about how to install this EGSnrc. Basically, EGSnrc is a toolkit which is an repository of GitHub portal. So you can go to the GitHub website and you can search for EGSnrc. You can get this web page. In this web page, you can get the um, manuals of all the models which we have seen in our previous slides, and there is a document is available for the installation also. So if somebody couldn't follow the steps which I am going to explain in this session, you can directly refer the installation manual. It will be very useful for this for to use this EGSnrc. So these are all the documentation which are available in this website. So my suggestion is to download these documents and go through these documents, so which will help you to use the EGSnrc most efficiently. So there are some prerequisites before installing the EGSnrc. The photon compiler. Uh, as I said, the some of the applications runs on Morton compiler. The both are if you download this photon compiler, it will run as a Morton compiler also. So C compiler, C++, and GNU utility, Git for cloning purpose, and active TLC. It is an GUI tool which is very useful when we interact or interpret with the EGSnrc. And Grace or Qt Grace is used for plotting purpose. So in this installation manual, you can able to see there are three options. One is for Linux, and one is for Mac, and one is for Windows. Today we are going to see about how we can install in the Windows platform. So once we click on this, once we download, once we see this installation PDF, there you can find the Mingvi folder, Mingvi hyperlink. It is a compiler, so we need to download this software first. So if you click on this hyperlink, it will take you to this page, which is SourceForge. There you can download the latest version of Mingvi. Mingvi is a compiler, so we need to download this. So while you're doing the installation of this Mingvi, you need to keep these settings for the better performance of EGSnrc. So that is the recommendation. So once you download, once you install these things, so once you install Mingvi, you can able to see a folder in your C drive. So after this installation, we need to set the environmental for this EGS toolkit. For this, you need to search in your system as environmental variables. This pop-up window will come. There you can set the path of this Mingvi folder, especially in the bin folder. You need to give the path as Mingvi bin. So after setting this environmental, it is advisable to restart the system to get a better performance. After restarting the system, if you go to the command prompt and you have to type this command prompt such as ming32 make.exe hyphen version. So if you run this prompt, you can get the make version of this Mingvi. You can able to see the version of this Mingvi. So once we install that, we need to install ActivityCL. So this is an GUI tool. So if you click on this, the hyperlink, which is in the installation PDF, So that will take you to this web page. There you need to select the uh, uh, Windows installer, and you can download this software. So this has a default setting. You no need to change anything. With the default setting, you can install this TCL. So then we need to download the Git. Git uh, Git for if you search Git for Windows, you can able to see this web page. The first link will take you to this web page. There you can download the Git. Once you download the Git, we need to install the plotting tool. So it's a Qt plotting tool. So if you click on this hyperlink, it will take you this again this SourceForge website. There you can download the Qt software. Once you download this software, it will be in the zip file. You need to extract that file, but my suggestion is to extract this file into C drive, so that it will be very useful to use this application. So here comes the main part. So there are two methods are there for installing the EGSnrc. One is they have given the master file of EGSnrc. It is a zip file. You can download that zip file and you can download the EGSnrc. But the other way is you can clone this. You can clone with the repository. So that is a highly recommended method. So once they have given the command for the GitHub cloning. You need to just copy this command and you can paste on the your command portal. So once you enter, it will start the cloning. Once it has cloned, you will get the message the installation has been done. Then we need to download the EGS configure for Windows exe file. So this is the important file. We need to import this configuration file. Before that, if you clone this repository, you can able to see the folder of EGSnrc in your C drive or whatever you have, whatever path you have given to this repository. So after that, we need to install this EGS configure file. So there they have given the hyperlink. You can able to see here the release page. So if you click on this page, it will take you to the web page. There you can download the EGSnrc configuration Windows file. If you start the installation, this is the pop-up message will come. So then click on the next. So here we need to give some paths for this installation. So here the second in this second line, you can able to see the system location for henhouse. For henhouse, you need to browse and you need to set the path which you have downloaded in the C drive. And the second one is EGS home. For EGS home, you need to give the path of EGS, but you need to create a separate folder. There won't be any henhouse folder. You need to create the EGS home folder. Then you have to give this path for this installation. The main purpose is EGS henhouse. I will talk about this EGS house and EGS home later. So we download this with typical settings. If you click on next, it will take you to override the parameters. Click on this yes and continue. You can continue. So once you continue, this is the pop-up window will come. The main thing is you need to check this environmental. So without checking environmental, it will not work. So we need to check this environmental. There is a checkbox is there. We need to check this environmental and click on the installation. Once the installation done, so this is the message you can get, or EGS GUI shortcut added to your desktop. So you can able to see there are uh, 4 or 5 shortcuts are available in your desktop. So once you finish the installation, click on the finish. So this is how we need to install the EGSnrc on Windows. So in-house, as we have already seen, in-house and EGS home. So this in-house, if you open this in-house folder, you can able to see these many folders are available. So these are all some make files. It contains some make files, some uh, uh, pegs file, some macros, some face-based files. So these are all some default modules they have given. So with the help of this henhouse, we need to take we need to take inputs from this henhouse for for example, for the linear accelerator construction, or if we want to do some dose calculation, we need to get some input from this henhouse folder. That is why it is a default folder. And the another one is EGS home, which is our user folder. So whatever you have constructed linear accelerator, or whatever you did some calculation, that all the data will get saved in this folder. So it's an user folder. So that is the difference between the hen home and the EGS home. So let's talk about this BEAMnrc. So I'm going to explain few modules only, because if you try to explain all the modules, it will the due to the time constraints we cannot able to do all the things. So BEAMnrc, uh, first BEAMnrc, we need to specify the accelerator, and we need to compile. Uh, for doing the simulation, we need to get the cross section data from the hen house, and we have to give some inputs such as geometry, incident beam, and simulation parameter. So it will do the simulation, and you can get the phase-space files and output listing, graphics, and these 3 things. So from these phase-space files, we can analyze the phase-space file itself, or we can use these phase-space files for the dose calculation in the patient data. So this is how the BEAMnrc GUI look like. Mm, so if you click on specify new accelerator, we can create a new accelerator by clicking the specify a new accelerator option. So these are all the modules which are all inbuilt models are available. From these models, you can select these models to get what are all your requirements. For example, if you need MLC, you can input this module. If you want to do if you want to do electron, you can select applicator module. So in this way, we can generate the linear accelerator. So this is also an option. So this we compile this accelerator. So these are all the input parameters. So in this session, we are not going to discuss anything about this input parameters, because this due to the time constraints, if I start explaining all these things, it will take more than 2 hours. So I'm going to show what are all the options, how we can how we are going to see when we install this EGSnrc. So these are all the input we have to give for the BEAMnrc. So as I said earlier, there are so many documents are there. For BEAMnrc also there is a document. So in that document, they have explained all the modules for the construction of linear accelerator. So this is one of the module slabs, which is mainly used to construct the target of the linear accelerator, and cons 3, cons stack, these are all the modules which are used for this primary collimator. Flattening filter is used for flattening filter, and this module is used for chamber and for JAWS, for MLC. So this is how the constructed linear accelerator look like. So in this, we could able to see on the right side, we could be able to see the materials which are used for this construction of the linear accelerator. So we can start from the target and collimator, windows, flattening filter, chamber, Mylar mirror, shielding, and XY jaw, everything. So once we constructed the linear accelerator, with the help once we simulated the particles in the linear accelerator, that particle or phase space files we could able to use in the XYZnrc for the dose calculation. So this is how the DOSXYZnrc GUI look like. So this is a input window. We can give inputs to this module. We can create phantom, or we can straight away we can give the CT images. So we can give number of histories. Number of histories. If you do simulation with more number of entries, which means if you simulate 10 crore histories, the results which we will get is more close to the measured data. So as the number of histories increase, we will get the more accurate calculation and the dose distribution. So this is how the DOSXYZnrc calculated distribution look like. So till this time we have seen the modules which are run based on Moton or Photon language. I have explained, or sorry, I have given a brief intro about this BEAMnrc and DOSXYZnrc. So there are so many applications are there. If you want, you can go through this installation. Sorry, go through these documents, and you can utilize the documents. So there are few applications that are runs on C++ language. So EGS++ is a separate application. Below that application, there are so many models are there: EGS chamber, EGS CBCT, and so many applications are there. So this is a simple coding or programming for to construct the chamber. So this is how the program format look like. So we can give the dimension of the chamber, and yes, we can get the, so we can give the dimension, and we can give the dimension of the phantom here. So you can see the geometry. Sorry, you can give the you can give the dimension of the phantom also. So in this manner, we can do the Monte Carlo simulation in EGS module also. So this is how the constructed chamber look like. So then, okay. So for Monte Carlo simulation, there are three major steps are there. So one is collecting the phase space file in the plane one, which is patient independent components. From the target to the Mylar mirror, it will not change. It depends upon the patient data. So it will be a stable one. Only the energy, if the energy is changed, then the data will be changed. And with the help of this phase space file, which are collected in plane one, we need to collect the phase space file at the plane two, which has the patient dependent components such as JAWS, MLCs. If we calculate for electron, we need to include the applicator. So with the help of after measuring the phase space file at the plane two, we can use the phase space file on the patient data to get the dose distribution. This is the basic workflow of Monte Carlo simulation. So you can construct a linear accelerator using BEAMnrc, and you can get the phase space file of plane one. Otherwise, one more option is there. The option is you can get the phase space file directly from the IAA website. They have listed some of the phase space files of some linear accelerator. So you can use this linear accelerator, sorry, use these phase space files, and you can reduce your calculation time and you can do efficiently for our research purpose. So that's all I want to say. And one more thing, here with this session, we're going to give some useful YouTube links, and we're going to give the GitHub repository link also. So that will be very useful for your future work. And thank you. If any questions, you can ask questions. Okay. Hello. Yes. Sorry, there is a. Okay, there is an issue. Please wait for a few minutes. Oh, yes. Now we can ask questions.
Sir, good evening, sir.
Good evening. Good evening.
Actually, it was a nice presentation, sir. Very big thanks to you.
Okay.
And my question is that whether I have R5 processor, sir. It is compatible to run this in this processor?
It is. It depends upon how much particles you're going to simulate.
Okay,
if you
sir.
simulate more than 10 crore,
Yeah.
so what is your RAM configuration?
It's around 8 GB, sir.
Okay, 8 GB is not enough. So
Okay.
you need at least 32 GB RAM.
Okay, sir.
For this you need some 32 GB, and one more thing I forgot to tell you, and you need some for around 500 GB hard disk also in space, because the each phase space files contains around 1 GB. So if you do simulation, if you keep on doing the simulation, you need to get some space to store that phase space files.
Yeah, okay, sir. The storage is not an issue for me, but the RAM
Okay.
and the processor is an
Okay. Because
is there any other option, sir, which we can switch to?
are you a very user?
Yeah, sir.
You have a T box, right?
Yes, sir.
Okay, if it is possible, you can run the software on T box, because I started there only. That's because it has 32 GB RAM.
Yes.
So, okay.
Yes.
And the processor is also some Xenon process is there. So it has high configuration. So you can use of that system for the calculation.
Okay, sir.
Thank you so much.
I will try.
Thank you.
Yes.
Thank you so much.
Thank you. Thank you for
So please, any other questions you can ask me. Because I am also in the seashore, so I have a little experience with the EGSnrc, so not that much.
Hi, sir. Good evening.
Good evening.
This side Venugopal here.
Okay, thanks.
Sir, sir, I just want to Sir, it was a very nice presentation.
Oh, thank you so much.
Sir, I want to ask that for a beginner, how much time will take to learn if you take it very seriously? Means it's like a very easy from the if you start from the scratch. Sir, how much time will take?
Okay,
Uh,
how much time will it take? It's so as I said, we're going to give you the YouTube link. So each uh, YouTube videos contains more than 2 hours of information. So you can go through these videos. It will be very useful because I learned this tool from that videos only. Uh, if I ask me how much time, I cannot say really the time.
okay, sir. Okay.
Okay, it
Okay.
will be useful if you go through these videos. And I'm going to we are going to share the one discussion forum
Okay.
that will be also very useful if you have any doubt or if you have any problem with the installation or simulation. You can directly post that problem in that forum. You can get the answers because the forum is run by the developers who develop this software. They are running this they are running this forum. So if you post any problems in that forum, you can get the answers.
Okay, sir. Thank you so
Okay,
much.
thank you.
Good evening, sir. This
Good
side
evening.
Alvin.
Oh, yes,
Very
Alvin.
nice presentation.
Thank you.
Sir, regarding that, you have mentioned a history, like
History.
entering the value 10 crore
Yes,
plus.
yes, yes, yes.
What's that actually? I didn't get it.
Because in our presentation first we have seen the random sampling with the repeated iteration. So
Okay.
it's kind of iteration. You are giving some random inputs with some
Okay.
iteration. That number represents the iteration. So
Okay.
these many iterations you need to do, or these many particles you need to simulate. That is the basic idea.
Okay. Regarding particles, it
Yes,
is.
yes, yes.
Okay, sir. Thank you.
Thank you. So, any other questions, or else we can wind up this session. Okay, I think there is no questions. So, thank you to all for attending this session. Thank you so much.
Thank you, sir.